we have a uniform rod of mass m and length L0 is rotating with a constant angular speed omega about a vertical axis passing through suspension. The moment of inertia of rod about the axis of rotation, if it makes an angle theta to the vertical, that means suppose this is our vertical, and this rod is making an angle theta with the vertical like this. Let's say the length of the rod is L. Then what will be the moment of inertia? See, we know for a rod which is rotating like this with the length L, the moment of inertia is ml square by 12. That we know already. So that is easy. But what about this? Okay, what will be the moment of inertia if the rod is made at an angle theta with respect to vertical? So how will you find that? So let's look at this. If the rod is making an angle theta with the vertical, then what will be the scenario? So let's look at this. Suppose this is our rod, okay? This is angle theta. And let's say this is at a distance x. We have taken a element, small element, dx, okay? This is dx. And let's say this dx element has mass dm, which is equal to lambda times dx, because lambda is mass per unit length, right? So lambda is equal to dm by dx. Lambda is equal to dm by dx, mass per unit length. So now the moment of inertia formula, if we use, what is the moment of inertia formula? For the small mass here, which is dm, okay, we have the moment of inertia as this distance square. This distance is x sine theta. This distance is x sine theta. So this distance square, that is x sine theta whole square, okay, into dm, and we have integral. So divided by integral over dm, right? So integral over dm is simply the mass, capital M. Okay, now dm can be written as lambda times dx. So lambda is constant. So lambda is here outside, so x sine theta whole square into dx, right? Correct. So this is lambda times sine square theta will be constant, so it will come out. This will be x square dx divided by m. So this is lambda is mass per unit length, so m by L sine square theta by m. If we integrate from 0 to L, we get L cube by 3. Okay, so m gets cancelled. We have, sorry, we don't have integral over dm in this equation, right? There will be no integration over dm in the denominator. So this will not be there. Okay, so this is 0 to m. So this is m. This is for, that is for center of mass, right? We do that for center of mass, for not for moment of inertia. So this is m by L sine square theta into L cube by 3. So this L gets cancelled. We have L square. So this is ml square sine square theta by 3. ml square sine square theta by 3. For a rod which is horizontal, the answer is ml square by 3. ml square by 3. Previously I said ml square by 12, that was by mistake. This is ml square by 3, not ml square by 12. This is ml square by 3. Now if the rod is suspended like this, always remember the component of this length perpendicular to the axis will be your new length for the moment of inertia. That means you have to take L sine theta for that length. So the rod moment of inertia is ml square by 3. So instead of ml square by 3, you will put L sine theta whole square by 3. Okay, like that. So here the correct option will be this one, fourth, ml 0 square sine square theta by 3.